We need some kind of other way to figure out a solution if, when we graph it, it doesn't come together as an exact ordered pair, right? Because if we're trying to do that, then it's approximation. And that's not really going to work, okay? We also need a variety of methods of solving this just in case the system is set up a particular way, okay? So the setup that we are looking for in order to do substitution, okay? The setup that we are looking for here is either x equals some stuff or y equals some stuff, okay? Because if we have x equals some stuff or y equals some stuff, we can easily substitute, okay? So I want to pull over to the side really quick, and I want to show you just something that you already know how to do. Okay, let's do this problem just anywhere where you have some free space. Let's do this problem. So let's do, I want you to find y, okay? So I want you to find y, and I'm going to give you two equations to work with here. Actually, one equation and one other piece. So let's say we're going to do x plus 2y equals 12, and I'm going to tell you that x is 3, okay? So I want you to go ahead and find y given that equation and knowing that x is 3. Can somebody tell me how you began to attack this problem? I know you're probably not done yet, and that's okay. How did you begin to attack this problem? What did you do to start? Come on, guys, don't be shy. How did you begin to attack this problem? What did you do first?
Plug in 3.
Yeah, you plugged 3 in for x, right? So anytime we know here that x equals a number, or if we knew y equals a number, we are literally just substituting it in, right? So we know x is 3, so we're just going to take this 3 and substitute it in for x, okay? So we have now, we're going to take that, plug it in right there. So now we have 3 plus 2y equals 12. So now I have an equation with just y in it, right? So now I can solve for y just like what was asked, okay? So I would subtract 3, have 2y equals 9, divide by 2, and y equals 4.5. Okay, or 9 over 2, right? That is a very, very simple problem that you guys know how to do. We are going to take this exact same scenario and apply it to something that's a little more challenging, okay? It's exactly the same as this problem right here that you already know how to do. We're just going to apply it to something a little more complex, okay? All right, so let me get rid of this. Let's pull back over to the typical or the normal notes. And let's look at number 1, okay? So now, instead of x equals 3, what do you know in this equation? What do you know in this equation? Do you know x equals something or y equals something? What do you know y equals? It's not just a number, right? What does y equal here?
5 plus x.
Yeah, 5 plus x, right? So instead of just x equals a number or y equals a number, now we have x equals an expression or y equals an expression. It's the same exact concept. So let's talk goals, okay? Let's talk goals. Remember, our goals here are to know what x and y both equal. We cannot do that when we have two equations that both have x or y, right? If you have an equation that has x and y both in it, you can't solve down and get x equals a number or y equals a number, okay? So substitution is going to allow us to take two equations with two variables and turn it into one equation with one variable, okay? So as we stated, we know that y equals 5 plus x. On the other problem that we just got done doing, when we knew x was 3, we took 3 and plugged it in for x. So now that we know y equals 5 plus x, we're going to take 5 plus x and we're going to plug it in for y in the other equation. Okay? So now that top equation is now 2x plus 2, and in place of y, I'm substituting in 5 plus x equals 10, right? So in place of y, I'm plugging in the 5 plus x. Okay, let's just stop right there. Can I get a comfort level for what I just put on the board? A 3, 2, 1, 0. How are you feeling about what I just put on the board as far as understanding it and being able to replicate that? Good. We're feeling pretty good about that. Okay, good. So the rest is just solving equations, just like we had early in the semester, right? Because now you see one big equation with just x in it. Okay? So let's do a couple steps to solve. All right, so I need to get rid of parentheses, so I'm going to distribute the 2 in. So 2x is going to hang out front. 2 times 5 is plus 10. 2 times x is plus 2x equals 10. Okay? I'm going to combine like terms. They're on the same side of the equal sign, so I just combine them like I see them. 2x and 2x makes 4x. Bring your plus 10 down. Bring your equals 10 down. Now that I've simplified as much as I can, remember, same side simplify. Now that I've done that as much as I can, now I need to subtract 10 from both sides. So now I'm doing my opposite operation. Okay, so I subtract 10 from both sides. I have 4x equals 10 minus 10 is 0. That's okay, right? 0 is okay. One last step to get x by itself, I divide by 4. And I end up with x equals 0, right? Alright, so there's part of my answer. I know you guys wanted to think that we were done, but we're not quite, right? What did all of our answers look like to the graphing systems equations or problems? What did our answer always look like? Last night on your prep. Yeah, it was an ordered pair, right? It was an x and a y value stuck together. So now that I've found one value, now this turned into the problem that we had just a minute ago, where I'm just taking that value and plugging it in. Okay? So you come back up to one of your 2 original equations up here. You plug your x value in that you've already found, and you solve for y. So if I'm going to solve for y, I think it's going to make most sense to use this bottom equation. So let's use this bottom equation. Oops, wrong button. There we go. Okay, let's use the bottom equation. And now I just have y equals 5 plus, what's x? 0. So 5 plus 0 is 0, so y equals 5. Okay, so let me actually get rid of this box down here because that's not my final answer, right? Why isn't it letting me? There we go. Okay, so we have x is 0. We have y is 5, so my ordered pair is 0, 5. That is my final answer. Okay? Your final answer needs to be an ordered pair just like it was when we graphed. Okay? So you need to look for an x equals or a y equals. That's typically showing you, hey, we're doing substitution. Once you have an x equals or a y equals, then you are going to move into the substitution phase. Solve down for one variable. Once you have that one variable, plug it back in to find the other variable. Okay? All right, let's try number 2. I know this is a complicated process, okay? But I promise you, as you practice it more, it won't be that bad. All right, so let's start by substituting. So do you know x equals or y equals? X equals, right? So we know x equals this stuff. So I'm going to take that stuff and I'm going to plug it in for x. So whatever your variable that's isolated is that's where it's going to substitute in, right? All right, so now let's rewrite our equation. So we have 2. In place of x, I'm plugging in what x equals, which is negative 2y minus 1. Okay, then I bring down my minus y, and I bring down my equals 3. Okay? So all I did there was substitute that stuff in for x. Okay, this is where you want to stop and double check. So stop and double check. Do we have an equation with just one variable in it? Just one type of variable in it? We do, just y's, right? So now I'm going to go ahead and solve for y. So I distribute the 2 in. So I have negative 4y minus 2. Bring down your minus y, bring down your equals 3. Okay? My y's are both on the same side, so I'm just going to combine them as I see them. Negative 4y and negative 1 more y makes negative 5y. Bring down my minus 2. Bring down my equals 3. And now I'm just solving. Add 2. Do your opposite operations. Negative 5y equals 5. Divide by negative 5. And y equals, looks like negative 1. Okay. Once you find one variable, then you just substitute back in to find the other variable. Okay, so since we know y equals negative 1, I'm going to go ahead and plug that in for y. Remember, you can choose either equation, okay? But if I'm trying to find x, I'm going to choose the equation that's x equals. So I'm going to use the bottom one. So I have x equals negative 2, y is negative 1, so I'm going to plug that in. Minus 1. So negative 2 times negative 1 is positive 2. Okay, and then 2 minus 1 is just 1. So x equals 1. So I figured out that y equaled negative 1. I figured out x equals positive 1. So my ordered pair is, oops, almost put it backward. Positive 1 comma negative 1. Okay, so answer should always be ordered pairs. All right, let's get a comfort level of where you are with this process, the entire process. Okay, let's see one more. If you feel comfortable, you can go on to the other practice problems down below. But if you would like to see one more and work through it with me, I'm going to do that one more time. Okay? All right, so we have x equals here, right? So x very simply equals y. So I'm going to take y and I'm going to plug it in right there because x equals that. So that's what I'm plugging in for x. Okay. So I would have y minus 3y equals negative 1. This one's almost so simple that it's confusing, right? So x and y are just interchangeable here. So that's why I substituted y in where I see x. So now y minus 3y is negative 2y. Equals negative 1. I divide by negative 2 on both sides. And y equals a positive 1/2. Alright, so positive 1/2 or 0.5, either way you want to roll with it, that's fine. Okay, now I have x equals y. And what's y? 1/2. So you know if x equals y, they both have to equal the same thing, right? So x equals 1/2, y equals 1/2. So my ordered pair is 1/2, comma 1/2. Do you think it would have been very easy to figure out 1/2, comma 1/2 if we tried to do this graphically? Wouldn't be very easy, right? That one would be easier than a lot of them are because it's a nice even 1/2, 1/2. But some of them get even more complicated where it's a lot more challenging to solve them via graphing. Okay? All right, so let's go ahead to the second. And let's have you guys practice doing, let's do 4, let's do 5, and let's do 7. Okay, let's do 4, 5, and 7. So you can mark out 6, 8, and 9. Okay, so 4, 5, and 7, I'll give you guys a few minutes here to work. Go ahead. All right, so let's go ahead and look at number 4. I'm going to kind of move through these at a quicker pace now since I'm assuming all of you have done them. But please stop me if there are any questions or anything, okay? So that we see here that y equals x plus 1. So that's going to go right there for y. So rewriting the top function, I have x minus 2. Y is replaced by x plus 1 equals negative 3. I substitute the 2 in, so I have x minus 2x minus 2 equals negative 3. I combine like terms on the same side to get negative 1x. Bring down my minus 2 and my equals negative 3. Add 2 over to the other side. I have negative 1x equals negative 1. Divide by negative 1. And x equals positive 1. Okay, so that's half of my answer. I need to substitute that back in. Since I'm trying to find y, I'm gonna use the y equals equation. So y equals x is 1 plus 1 more. Y is 2. So my ordered pair answer is 1, 2. Okay, any questions on 4? All right, let's look at 5. So this time we have x equals this stuff, so that's going in for x. So I have 2x is 3y plus 5 plus y equals 3. So I literally just copy the same function, just replacing x with what I know x equals. So now I'm just solving. So distribute in, I have 6y plus 10, bring down my plus y, bring down my equals 3. Combine like terms on the same side, so that's 7y plus 10 equals 3. Opposite operation to get rid of 10. I have 7y equals negative 7. Divide by 7 and I end up with y equals negative 1. Okay, so that's half of my answer. Since I'm trying to find x, I'm going to use the x equals equation. So x equals 3. Y I know is negative 1 plus 5 more. 3 times negative 1 is negative 3. Plus 5 more is 2. So x equals a positive 2. So then my ordered pair answer is 2, negative 1. Okay, any questions on 5? All right, last but not least, number 7. I don't know why, but this type of problem always seems to throw kids for a loop. Maybe it's because you have too many options. I don't know. So we have 2 y equals equations here, and that's okay. Okay, that's perfectly fine to have 2 y equals equations. That just means you have choices. Okay. Regardless of which choice you make, you're essentially going to come up with the same equation. It's just going to look flip-flopped depending on which choice you make. So I know that y equals this negative 2x right here. So I'm going to take that negative 2x and I'm going to plug it in for y right there, just like I normally would. Okay. So I plug my negative 2x in for that y equals 2x plus 8. So essentially what I'm doing when I have 2 y equals equations like this is I'm setting the 2 expressions equal to each other, right? So now I just need to solve for x. These variables are on opposite sides of the equation, so I do need to do an opposite operation this time. So I have negative 4x equals 8. I divide by negative 4 on both sides, and I end up with a final answer of x equal, well, I guess not a final answer, but an answer of x equals negative 2. Remember, that's half of my answer. The other answer is the y part, so I could really use either equation here. So which one do you guys want to use, top or bottom? What? Bottom? All right, I'm fine with that. So y equals negative 2 times x we know is negative 2. So y is going to have to equal a positive 4. So I have an ordered pair answer of negative 2, 4. So always remember to finish off your answer with the ordered pair there. Okay, comfort level. How are you feeling about substitution? Now that we've practiced some. 3, 2, 1, 0. Good. Good. Glad to see most of us are feeling pretty good. All right. All right, let's jump in to one more beautiful, amazing word problem. Okay? I know some of you don't like word problems and you shy away when you see words, but let's think about it, or let's be honest. What's the point if there's no word problem behind it, right? I mean, what's the point of just learning some lame math without some kind of application behind it? So let's do it. All right, so it says an adult ticket to the museum costs $3 more than a children's ticket. Okay? So an adult ticket costs $3 more than a children's ticket. Okay, that's important to know. It says 200 adult tickets and 100 children's tickets are sold. The revenue is $2,100. And then it wants to know what is the cost of a children's ticket. So what are the two unknowns here? What are the two things that I don't know about this equation or this problem? Yeah. Good. So let's make some variables. So what would you like the variables to be?
A and C.
Smart man. All right. So we're going to say A. I like to use capital so I don't mix them up with numbers. So A is going to be the price per adult. Okay. And then we'll say C is the price per child. Okay? So A is the price per adult, C is the price per child. So remember, last time we looked at these word problems, we talked about two totals. This time we don't really have two totals, right? We only have one total, and then we also have another piece of information. That other piece of information tells me that adult tickets cost $3 more than children's tickets. Okay? So adult tickets cost $3 more than children's tickets. So let's make an equation for that. Adult tickets, that's what we're representing by A, should equal, how do I do $3 more? What does that look like in math? Not a trick question. If I said this was the price, now tell me $3 more, what would you do mathematically? Good, you would just add 3, right? That's all you got to do. Okay, so I'm going to add 3 to the children's tickets, which is C, plus 3. So we know the adult ticket is $3 more than the children's ticket. That's my first equation. The second equation says 200 adults, so that's 200A, plus 100 children, so 100C, should equal a revenue of $2,100, right? So that's my second equation. Okay, then it wants to know what the cost of a children's ticket is, okay? So essentially what I need to do is I need to figure out C. But I got to be strategic about how I do that. So I pick a method. In this case, since we have A equals, substitution will work just fine for us. Okay, so since I know A equals C plus 3, I'm going to take that and substitute it right in there for A. So now I have 200 in place of A. Actually, you know, I'm going to run out of room, but that's okay, I guess. So I have 200 in place of A. I'm putting in my C plus 3. Okay, that's my substitution part, right? Bring down my plus 100C. Bring down my equals 2100. Okay, so now I'm just solving for C. So I need to distribute the 200 in. So I have 200C. Here, let me move up so you guys can actually see. Okay, so I have 200C plus 200 times 3 is 600 plus 100C equals 2100. Okay, so now I have like terms on the same side. 200C and 100C makes 300C. Bring down my plus 600, and that's equal to 2100. Okay, so now I'm just solving for C. So opposite operation to get rid of the 600. So I have 300C equals 2100 minus 600 would be what, 1500? Divide by 300. Nice easy trick for you if you're ever dividing big numbers like this. Remember, you can mark off 0. So 15 divided by 3 is 5. So C equals 5. What does that mean? Yeah.
The children's ticket is $5.
Good. The children's ticket is $5, right? So if you don't remember what you labeled your variables as, come back up, right? Because we see up there C is labeled as the cost per child. So then you can very easily make that connection and say that C is 5, so it's $5 per child. Okay? All right, the rest of the time is yours for prep.